Hello, this is 2373 Engineering Economics, and in this video we're going to be solving problems on arithmetic gradient. Problems 93, 94, and 95 of your book. You can find those on page 104. So let's start from problem 93, and I read the problem. To withdraw $800 from a saving account at the end of year 1, $900 at the end of year 2, $1,000 at the end of year 3, and so on over a total of 5 years. How much money must be on deposit right now at the end of year 0 to just deplete the account after the fifth withdrawals if interest is 5% compounded annually? So from the statement of the problem we can extract the following information. Annuities are $800, and the gradient, since we're going to be increasing the amount to be withdrawn at every time, is $100. What we're interested in is into knowing how much we need to have right now, so that's how much we need to have in the present. The number of periods is 5, and the interest rate is 5%. So in order to find this answer, what we have is that the present value is equal to 800 times P given A for 5% and 5 periods plus 100 times P given G 5% and 5 periods. So when we enter these parameters in the formulas, we find that P given A 5% and 5 periods is 3.79078, and P given G 5% and 5 is 6.86180. And when we do the corresponding operations, the present value that we have is $3,032.63 plus $686.18, or the present value is $3,718.80. Okay, we now continue with problem 94, and also on page 104. Deposits are made at the end of years 1 through 7 into an account paying 6% per year interest. The deposits start at $5,000 and increase by $1,000 each year. How much will be in the account immediately after the last deposit? So this being problem 94. We have the data is the number of periods is 7. The interest rate is 6%. The gradient is $1,000. The annuities is $5,000. And the question is how much will be at the end of the 7 periods, so we are asking for a future value. the account pays 6% per year. So in this problem we're looking for a future value. The formulation of the problem would look like the future value is equal to $5,000, which is the annuity, times F given A, 6% and 7 periods, plus $1,000 times F given G for 6% and 7 periods. The factors, when we use the formulas, translate into 8.39, 38, 37, and 23.23, 06, 3, and therefore the future value after all the computations is equal to $41,969.19 plus $23,230.63, and the future value is $65,199.82. And that's problem number 94. The next problem is problem 95. And the problem reads: a small company wishes to set up a fund that can be used for technology purchases over the next 6 years. Their forecast is for $12,000 to be needed at the end of year 1, decreasing by $2,000 each year thereafter. The fund earns 8% per year. How much money must be deposited to the fund at the end of year 0 to just deplete the fund after the last withdrawal? So this is problem 95. And from the data that we just read, we gather that the annuity is $12,000. The gradient is negative $2,000. And the interest rate is 8%. And the number of years is 6. And the question is the present value. So we write the present value should be equal to $12,000 times P given A for 8% and 6 periods, plus, no, not plus, but negative, minus $2,000 times, that this is the gradient, P given G, 8% and 6 periods. Now the factors that we find are 4.6, 288, and 2.5, 8,975, and when we do the math associated to this, the present value becomes $50,295.05. Remember that the quantity here would be 2,000 is negative times 2.58, and therefore it has to be subtracted. And that's problem 95.